Okay, let's go through the 2017 calculator paper. Again, pause videos, have a read of the questions, see what you think, and if you're stuck, you could watch how I go through the questions. Up to you how you want to do it. But yeah, definitely have a wee go at the questions. Don't just kind of listen, have a think, what would you do, even if it's just what's your strategy, and then you can see the finer points. But the more you stick in and you do these things, I absolutely guarantee you the more you will learn. So, classic question, we've got our triangle, we've got some coordinates. I would say a top tip is drawing your coordinates so you don't make a little mistake. When they've not told us what A is, told us B. I love how something says to score out what you've used as well. So we've used that, fantastic. And the broken line is the perpendicular bisector of BC. So I think what I would do actually is I would just draw that in, just to remind me that that is the bisector, and then I'll just score that out as well. So everything now that's up here, I really do have on the diagram. So find the equation of the perpendicular bisector of BC. Okay, so usually I start these questions with a point, gradient, equation, kind of heading. Remember your gradient is y2 take away y1, x2 take away x1, so it's just the difference of the y's divided by difference of x's, i.e. height divided by length, and this equation for your general equation of a straight line. So that's a nice place to start off with. So for this one, I'm looking for the perpendicular bisector of BC. Well, I'm going to need a point on the line, and I'm going to need a gradient. So I'm going to need this point here, and I'm going to need the perpendicular gradient of this line. So my point, I'd be saying, is the midpoint of BC. A big space for this one. And my sum for that will just be the x's added together, divided by 2, and the y's added together, divided by 2. So that's going to give me, what's that, 12, so 6, and then negative 2, so negative 1. Fantastic. So right away, we've gotten 1 over 4 marks for that. Next thing to do is work out this gradient. So here I'm going to say that MBC, the gradient of BC, is equal to that. And we'll do that as well. So I'll say, let's call that y2, take away y1, divided by x2, take away x1. So that's going to give me 2 divided by negative 6. So that's negative 1/3. And the perpendicular gradient will therefore be positive 3. And that is worth 2 marks. We get this and this. So now I know my gradient and I know my point. I can substitute them in. So I'll say that y, take away the negative 1, will be y plus 1. And if you want, pardon me, take your time. A and B. Don't rush these things. There's no point for finishing first. The gradient is 3, and x, take away A, which is 6. So y plus 1 is 3x take away 18, and then take away your 1 for negative 19. Final 4th mark. And again, just to remind us, this is our gradient and this is our y-intercept. To get a gradient from this equation, it has to be of the form y equals. Some of the questions you'll get will be something like 3y is equal to x plus 2. What's the gradient? Well, you'd have to divide through by 3 to get y on its own. So don't forget your y equals mx plus c. And yeah, that's part 1 done. Let's have a look now at part 2. Line AB makes a 45 degree with a positive direction of the x-axis. Find the equation of line AB. Oh, so that's our line here. There you go. So they've drawn it in quite handily. Okay. So they're saying that this is at 45 degrees. What's the equation of the line? Well, again, you're going to need a point, you're going to need your gradient, and from that you can work out your equation. So do I know any points on AB? Yes, I do. I know I've got 3 and I've got 0. So you either need 2 points, so you can work out a gradient and then get your equation, or if you know 1 point, you can then work out your gradient some other way. And the question seems to be getting me to work out the gradient using the angle formula, doesn't it? So for this one, it's saying, well, m is tan theta, so the gradient is tan of 45. And then you're down to your exact values, just remember. So that triangle, well, there's 2 triangles. I'll draw them both out, Obviously, these aren't to scale or anything. But you've got your 1, 1, root 2 triangle, where you've got 45 and 45. And you've got your 1, root 3, 2 triangle. And for that one, I always remember that the 30 degrees goes next to the 3, which would make this 160. So obviously, yeah, we're using this triangle. So the opposite over adjacent, because I know that m is opposite over adjacent because it's it's tan. That's what gradient is. It's like your height over your length. So that's going to be just 1, isn't it? Yeah, fantastic. So my gradient is going to be 1 for this one. So I'll just put down there m equals 1. And we should really know that actually. It makes sense, doesn't it? A 45-degree line is your standard, that's kind of going up 1, going along 1. That's your standard line there, So we should really be thinking, okay, yeah, makes sense to me. But just, these triangles might have come in handy if they were wanting you to work out a slightly tougher gradient. And don't forget, if the line's going in this direction, the way BC is, so say this is the same kind of question with BC, you'd be looking at this angle in here, not this angle in here. Okay, so just watch out for that if you go on these questions. And then we can say, right, equation, so y minus b, again, just take your time. So y minus b is equal to m, which is 1, x minus a, which is 3. So y is equal to x, take away 3, which makes sense because y equals x is that standard 45-degree line, and negative 3 looks like it's going to cut here, negative 3. Yep, I could get my head around that. Only 2 marks, tiny bit harsh, I feel. So, well, maybe not, actually, maybe not. So you get a mark for this and a mark for your final answer. Yeah, and the last bit, find the coordinates with the point of intersection of AB and the perpendicular bisection of BC. So now it wants you to find where these two lines are meeting. So to do that, you need to write down your 2 equations, okay, and then you're going to use simultaneous equations. So right away, I've got the same number of y's, so I can just treat these like 2 equations. I don't need to change them. So I call that A and I call that B. I think if I do B take away A, that will be sufficient. So B take away A, this becomes 0. So because they've got the same coefficient in front of the y's, I can start to cancel out. If I didn't have that, I would have to multiply the equations by something. And if I'm doing B take away A, that's going to be 2x, and negative 19 take away negative 3, so I'm adding on 3. So it's going to give me negative 16. Very good. So that means that x is going to come out as, well, I'll just say 2x is equal to 18. So x is equal to, 16. So x is equal to 8. And then just sub it back in. So for that one there, y is going to be equal to 8 take away 3. So y is equal to 5. Oops, I need to do that. And let's see what our points. Yeah, just a point each for each of these. So if you wanted to write it as a coordinate, you're saying that they're going to meet at 8, 5. Okay. So yeah, very classic question for your start of the paper. I hope you're thinking there's nothing new there. Probably the trickiest bit, I think, this question doesn't come up as often. The angle question. So you might want to bone up on that, just how we read. But this is very standard, when you're looking at your point gradient equation and you're looking at either, 2 points to get the equation, or you're looking at 1 point and then a gradient. And the gradient will be the perpendicular gradient or the parallel gradient. They'll dress up the question like that. So I think these part C and part A very, very common. This part's slightly less so. So maybe you want to just dig into some of the angle questions in other papers if you want to look at that. And just, be careful that you're using the correct angle. Okay, nice. Hope that's helpful.